Very good morning. Uh, we were discussing the fifth module. As I told you, in fifth module there are two parts. First part is numerical solution of second order ordinary differential equations, and second concept is this calculation of variation. So in first part we have studied how to solve the second order ordinary differential equations by using RK method of order 4 and Milnes predictor and corrector method. So their procedure was, you need to reduce the second order ordinary differential equation into first order ordinary differential equation and then use the regular method. So those two methods are in the first part of this module. So the second part is we have variations problem or calculus of variations. These concepts you have studied, some basic concept, not whole thing. Basic concept you have studied in PUC as well as in first semester. So this calculus of variation is related to finding the maxima or minima. So in general we say extremum, maximum or minimum or extremum of some function. So in PUC also you have studied, in first semester also you have studied. I think in first semester second module how to find the maxima and minima, or how to find the extremum values of some function of two variables or function of three variables, correct? So here also same thing, in calculus of variation is nothing but it is a powerful technique for the solution of problems in dynamics of rigid bodies, optimization of orbits and vibration problems. So the physical application are like this: optimization is nothing but finding the maxima or minima. Okay. You might have studied this optimization problem in PUC, like a graphical method, yes or no? Finding the maximum or minimum. Similarly, manual method also you have studied in PUC as well as first semester. Now we have continuation of that. If you know those basic concept, this will be very easy to understand. So the subject primarily concerned with the finding maximum or minimum. In general, we say extremum value of a definite integral involving a certain function. So it is change what you are going to study here. There in first semester or PUC you had studied how to find maximum or minimum of some function. If I say extremize or find the maximum or minimum of some function sin x plus sin y at the point 1 comma 2, you know that how to find out. So sin x plus sin y is some function used to take f of x comma y equal to sin x plus sin y, and procedure and all you have studied. There used to solve simple function how to find the extremum value of some function. But in this module you are going to find the extremum value of some definite integral. Definite integral means integral with limits. So definite integral involving some certain function. So function will be given like in first semester of PhD, but that function will be under some definite integral. So how to find maximum or minimum value of some definite integral involving certain function is known as calculus of variation. Variation is nothing but a small change in some function. One function will be given, there will be small changes in that nature or anything. That small changes is called variation. So we have to find the maximum or minimum with respect to variation of that function under the definite integral. Understood? The basic concept or basic meaning of calculus of variation is nothing but we use this particular method or concept to find the maximum or minimum value of a definite integral involving a certain function. Okay. But as I told you, definite integral involving certain function means before understanding this function, you know, you have studied from PU first only you have studied what is the meaning of function, how to solve function and all. So basically what is the definition of function? Function is nothing but mapping from some numbers to number. You know that f from a to b. A is some set of numbers and b also some set of numbers. F is a function from a to b such that some sine 2x equal to some 2x plus y like that, or the function f from a to b such that f of x equal to 2x square plus 1. These are all nothing but function. which means function is a mapping from numbers to numbers. But here in this module, you are going to study functionals. Function is different, functional is different. Okay, functional means function is a correspondence from a set of numbers to set of numbers, mapping from numbers to numbers, which means input, if you give some numbers, output also you will get numbers only. That is nothing but function. Input also we are getting some set of numbers, output also we are getting some numbers. That is nothing but function. You have studied that. But functional is nothing but functional is a mapping from functions to real number. Understand the difference. In function, input is also numbers, output is also number. But in functional, output is number. See, output is real numbers, but input is some functions. We are giving input as some functions. After some operations, we are getting real numbers as output. That is nothing but functional. So you have to understand these two concepts clearly. Function means numbers to number. Functional is nothing but functions to real number. Suppose some input you are getting sin x as input and output some value you are getting -1 to +1, that is some range. So that sin x is input functions, that -1 to +1 is output. So mapping is nothing but mapping is from functions to real number. So these type of terms are called functionals. Okay, so this is very important. So in functionals there will be three terms. You know that in functions there will be two terms. One is variable x, second one variable y. Only variables will be there. You know that. Suppose f of x comma y equal to sin x plus sin y. How many variables are there? Only two. One is x variable, second one is y variable. But in functional there will be one more variable, that is called y dash, which means if we consider a function of the form f of x, y and y dash, where x and y are the variables and y dash is nothing but dy by dx, derivative of y with respect to x, and this x belongs to x1 comma x2, the limit or the range x1 comma x2, x1 comma x2 are some numbers or anything. Then the integral I of y equal to integration of this function f of x comma y dash between x1 and x2 with respect to x. So this type of definite integral is called a functional. So understand clearly, here x is variable, y is also variable, y dash is also variable. Y dash is nothing but dy by dx, derivative of y with respect to x. So integral limit is from x1 to x2. x1 to x2 means either it may be 0 to 1, 1 to 2, 0 to pi by 2, 0 to pi, anything. Then this type of definite integral is called a functional. Okay, this is the standard form of a definite integral or a functional. That's why we have discussed here. This subject primarily concerned with finding maximum or minimum value of a definite integral involving a certain function. So here which one is definite integral? So this one, integration from x1 to x2 is definite integral. This integral is involving some function. Which is that function? F of x comma y dash. So these type of terms are called functional. So function under the definite integral is functional. So how many variables you have? Three variables. One is x, second one is y, third one is y dash, and you are integrating with respect to which variable? X here. Okay, so here you can take any value for y of x here. Suppose y of x is any variable, then this integral gives some real value. Here just arbitrary example I am giving, standard form. Suppose in place of f of x comma y dash, if you take any function and integral limit x1 to x2, if you take any constant, and after simplification of this particular integral, you will get some real value. So therefore, this integral is mapping from function to some real value. After evaluating this particular definite integral, we are going to obtain some number or real value. So this is a mapping from functions to real numbers. So these type of integrals are called functional. Okay. So for example, I can write integration from 0 to 1 x plus y dash whole square. So you can see here, remember in this concept main variables are x, y and y dash. So here integration of x plus y dash whole square between 0 to 1. So if you simplify this, then we get some numbers. So that is nothing but functional. So here also integration of root of 1 plus y dash whole square between x1 and x2. So this is nothing but one more example for functional. So remember, functional is nothing but some certain function under the definite integral, and it is a mapping from a functions to real numbers. Okay. So this is the definition of functionals. Similarly, these are some properties not so important. Suppose if you take f of x comma y dash be a function, then delta f equal to dou f by dou y into delta y plus dou f by dou y dash into delta y dash. This type of definition you have studied in first semester also. Here dou is nothing but partial derivative of f with respect to y. Dou f by dou y dash is nothing but partial derivative of f with respect to y dash. Here delta is there. Delta is nothing but variational operator or small change. Variation is nothing but f is some function, delta f is a small change in the function f. Similarly, delta y is nothing but a small change in variable y. Similarly, delta y dash is nothing but a small variation or small change in y dash. Then we can write delta f as dou f by dou y into delta y plus dou f by dou y dash into delta y dash. Similarly, we can apply commutative rule for this operator delta, that is delta of dy by dx can be written as d by dx of delta y, which means you can take delta inside the derivative with respect to x. Similarly, if I equal to integration of f of x y dash from x1 to x2, then we can write delta of f of x y dash under the integration from x1 to x2, that can be written as integration from x1 to x2 delta of f of x y dash. This is nothing but just commutative law, you can say. Okay. These are all nothing but some properties of this variations and calculus of variation. We are not using these concepts anywhere. You just remember what is the definition of functional and what is the standard type of functional. The standard type of functional is nothing but I equal to integration of f of x y dash from x1 to x2 dx. So here the presence of y dash in f of x y dash in y I of y, I is nothing but a definite integral, helps us to discuss a few important applications of calculus of variations. For example, the main application of this calculus of variation is we can find the curve y of x of minimum length passing through 2 points x1 comma y1 and x2 comma y2, which means there will be 2 points, arbitrary 2 points you consider in xy plane. Consider two arbitrary points a and b, and there will be, we can draw so many curves, infinite number of curves from a and b, but which is the smallest distance from a and b? Which curve is the smallest distance from a and b? Which curve covers smallest distance from a and b? Anyone, can you tell me? A and B are any 2 points that we can draw so many curves from A to B, but which is the curve having the small less distance from A and B, minimum length from A and B, which is the minimum length between,
A to B.
yes,
Straight line from A to B.
yeah, straight line from A to B. You can draw so many curves, but straight line from A to B is the smallest distance from A and B. So to find that smallest distance between any 2 points, we are using calculus of variations. Correct? The smallest distance is nothing but minimization, minimizing the distance. So to find minimization, we are going to use calculus of variations. So in next classes, in application part, you are going to use, you are going to solve how to find the shortest distance between any 2 points, so and so. So many examples are there. Example, you will understand the basic application of this calculus of variations. So in differential calculus, you have discussed maxima and minima of functions. correct? Like in first semester or in PUC. But here we are going to deal with maxima or minima of functionals. So understand, there we have studied maxima and minima of functions, there you have studied, but here you are going to study maxima and minima of functional. Functional means there will be definite integral. Okay. Now after studying these basic concept, we have one important result to find the extremum, maximum or minimum. That result is called Euler's equation or Euler's equation. Euler's equation is nothing but this is the necessary condition to find the maximum or minimum of certain function, which means the statement says a necessary condition for the integral I equal to integration of f of x y dash from x1 to x2, which means a functional where y of x1 equal to y1 and y of x2 equal to y2 to be an extremum is that it should satisfy the condition dou f by dou y minus d by dx of dou f by dou y dash equal to 0, which means we can say that this integral I is either maximum or minimum if it satisfy this condition, which means dou f by dou y minus d by dx of dou f by dou y dash equal to 0. Suppose in example if they ask find the maximum value of this I equal to integration of some sine x plus y. So sine x plus y is nothing but your function f of x comma y dash. Then that sine of x plus y should satisfy this particular result dou f by dou y minus d by dx of dou f by dou y dash equal to 0. So it's very important result, and in exam also they will ask this state and prove Euler's equation. Okay, state and prove. Sometimes they will use statement and sometimes they will give like this. The question will be state and prove Euler's equation. Then you have to write the statement as well as we have to obtain this particular derivation. So here we shall try to prove this result. What we are going to prove here? We are going to obtain some condition for the integral I to be an extremum. Remember, this extremum is nothing but either maximum or minimum, both. Okay. So now here y of x1 equal to y1 and y of x2 equal to y2 are any two curves. So now what we shall do? First, we shall consider any 2 points in xy plane. A of x1 comma y1 is one point, b of x2 comma y2 is second point. Let y equal to y of x be the curve joining these 2 points A and B. Clear? So first I am considering this one y equal to y of x between A and B, which makes the integral I to be extremum, which means along this curve we have to find whether the integral I is maximum or minimum. So I am considering this particular curve y equal to y of x from A to B. So here where I equal to integration of f of x comma y dash dx from x1 to x2. This is nothing but the given integral. After considering this basic curve, what I will do, I will consider one more curve between A and B. All of you observe carefully here. First curve is y of x joining A and B. Now I will consider one more curve, that is y equal to y of x plus h into alpha of x. This h into alpha of x is nothing but the distance between these two curves. See here I have drawn one line. This line is nothing but distance between this original curve and the new curve what we have considered. But this new curve is also joining the same points A and B. But why I have written here y of x plus h into alpha of x? Because if you add this particular distance h into alpha of x to this original curve, then we get this second curve between A and B. So let y equal to y of x plus h into alpha of x be a neighboring curve joining these 2 points, points A and B, where h is some constant. The value of h is very small and alpha of x is some arbitrary function of x. so that at the point A alpha of x1 equal to 0 and at the point B alpha of x2 equal to 0. Why I have written here alpha of x1 equal to 0 at the point A and alpha of x2 equal to 0 at the point B, which means you can see here this distance is nothing but h into alpha of x. So here distance is h into alpha of x. What is the distance between these two curves at the point A and B? Do you have any distance between these two curves at the point A and B? No, because at the point A, these two curves coincide. Yes or no? At the point B, these two curves coincides. Therefore, there is no distance between these two curves at the point A and B, but here you have the distance as h into alpha x. So at the point A means I will consider x-axis as the line of reference. So at the point A, this distance is 0. So alpha of x1. So because here I have taken this point as x1 comma y1, so we shall take x-axis as the line of reference. So alpha of x1 will be 0. Similarly, at the point P, we don't have any difference between these two curves because these two curves coincide each other. So here also alpha of x2 equal to 0. That's why we are taking here alpha of x1 equal to 0 at the point A and alpha of x2 equal to 0 at the point B because those two curves coincide each other at A and B. Now we shall take this new curve equation 1 y equal to y of x plus h into alpha of x in the above integral in place of I. Therefore the value of I along the equation 1 is, so you have to understand clearly here step by step, so listen carefully. Our actual integral is I equal to integration of f of x comma y dash from x1 to x2. So here y is there. Y is nothing but our actual curve y equal to y of x. So now we have considered one more curve. What is that? Y equal to y of x plus h into alpha of x. So if you take this particular value in place of y, then the new value of I will be integration of f of x comma in place of y. What I should write? See, new curve is y of x plus h into alpha of x comma in place of y dash what I have to write. If y equal to y of x plus h into alpha of x, then y dash will be y dash of x plus h into alpha dash of x, because alpha of x is also function of x, y of x is also function of x, and you are differentiating y with respect to x. Therefore y dash will be y dash of x plus h into alpha dash of x dx. I have not done anything here, just I have taken this new curve along the integral I, then I will be this one, that is equation 2. Now you can say that the function is minimum or maximum for h equal to 0, because this integral I will be extremum for the value h equal to 0. Why h equal to 0? Because this h into alpha of x is the distance between these two. Alpha of x is some function of x. So this main distance is depends on the value h. H is some small value. So when these two curves coincides each other, when h equal to 0. When h equal to 0, these two curves become same, then we can find either maximum or minimum of the given curve. So what is the condition for extremum here? The condition for extremum here, h equal to 0. Why? Because these two curves coincide when h equal to 0. So that is the equation 2 is an extremum when h equal to 0. This requires di by dh equal to 0 when h equal to 0. So we shall treat I as a function of h. Now you should understand why we have taken di by dh equal to 0. If you understand this, remaining thing you can do. So now recall your PUC or first semester finding maxima and minima. So if you recall PUC concept, one function will be given. Suppose if I give f of x equal to x square plus 2x, find the extremum value of f of x equal to x square plus 2x. What is the procedure? Do you remember? If some function is given, how to find the maximum or minimum of that? Anybody? F of x equal to some function, anything it may be. F of x is the given function. So how will you find maximum or minimum? Anybody? What is the first step you have to find out there? Yes, okay. So f of x is the given function. Then you have to find the stationary value, stationary points for x. Yes or no? If you remember. So how will you find the stationary points? Stationary points are nothing but the values for x. Critical points are stationary points. Okay, just recall that. So how will you find the stationary points? Suppose f of x equal to x square plus 2x. You use to find f dash of x. Yes or no? F dash of x equal to how much? 2x plus 1. You have to find a derivative df by dx, derivative of f with respect to x, because f is function depending on the variable x. So you used to find df by dx, that should be 0. So by considering f dash of x equal to 0, you used to find the stationary points or critical points. Same way, instead of the function f, what we have? The integral I. Now we have discussed now this integral I maximum or minimum. It depends on which quantity? H, the constant h. There the function f is depending on the variable x. So we have to find f dash of x or df by dx. But here the integral I is depending on the value h. So what condition we should have? Di by dh. Understanding? I'm just connecting the PUC concept and this one. Instead of f you have I here, instead of x we have h. Here di by dx we cannot write because these two curve coincides only when this h value is 0. So maximum or minimum is depends on the value of h. So which condition is required here? Di by dh should be equal to 0, where I is the function of h. Clear? I hope it's understood this concept. You just recall the PUC concept. That's why I told you in last class, if you remember, before coming to next class, study maxima and minima. So you should understand this if you know that PUC concept. So after this, now with the help of this di by dh, we shall try to obtain our main result. Okay. So how will you obtain that main result means? Now we shall obtain di by dh from equation 2. So left hand side which term you have I, but we want di by dh. What will you do to obtain di by dh? We have to differentiate this equation 2 with respect to h. But can you differentiate directly? No. If this integral is not there, then we can differentiate left hand side as well as right hand side. But right hand side there is a definite integral, so direct differentiation is not possible. Hence you have studied one more concept, if you remember, that is called in first year Leibniz rule for differentiation under the integral sign, which means we can differentiate some function which is under the integral sign. That is called the Leibniz rule for differentiation under the integral sign. If you have forgotten, I will just explain what is this method means. So here you just see left hand side you have I and right hand side your integration is with respect to which variable? X. So apart from this variable x, which constant you have in right hand side of equation 2? We have x here, x is also variable, y of x is also variable, alpha of x is also variable, that is function. Apart from these three, which is the constant other than the variable x, which is that h. So h is the constant. So you have to differentiate left hand side I with respect to that constant h. So the left hand side we don't have any integral, so derivative of I with respect to h is di by dh. But right hand side we cannot differentiate directly because one is this integral sign, second one is we have so many terms here. One is x, y of x, h into alpha of x, y dash of x plus h into alpha dash of x. But we have to differentiate this right hand side with respect to which variable? H, because we are considering h as variable. I is a function of h. Now if you remember, we have to differentiate some function with respect to one variable and we have to treat other variable as constant. In that case, which differentiation we have to use? See, f is a function of x and y. I want to differentiate f with respect to x and I want to treat y as constant. Then which differentiation we have to use? Anybody? F is a function of x and y. I want to differentiate f with respect to x, but I should consider y as constant.
Partial.
Differentiating, yes, differentiating one function with respect to one variable and we have to treat other variable as constant. This is the concept of which differentiation? Partial differentiation. Name itself says partiality we are doing. X and y two variables are there. We are doing partiality. We are differentiating only with respect to x and we are treating y as constant. There will be partiality. So name is partial differentiation. So here also same thing. In right hand side we have so many terms, but our ultimate aim is to obtain di by dh. We have to differentiate with respect to h. So we have to use this partial derivative. So this concept is called Leibniz rule for differentiation under the integral sign. So left hand side is di by dh, right hand side is integration from x1 to x2 dou by dou h of f of x comma y of x plus h into alpha of x comma y dash of x plus h into alpha dash of x, and integration is with respect to x. Now next we shall keep this left hand side as it is. For this right hand side term, we shall apply chain rule for the partial derivatives in RHS. Again remember the first semester second module. Total derivative, chain rule, implicit function, composite rule, composite functions. You know that. So here dou by dou h of f of x y of x plus h into alpha of x comma y dash of x plus h into alpha dash of x, which means dou f by dou h, but f is a function of x, y and y dash, correct? So how will you apply the chain rule? You know that f is a function of x, y, y dash, and x, y, y dash is function of h. Okay, just remember first semester chain rule. See here f is a function of x and x should be function of h now. So chain rule will be dou f by dou x into dou x by dou h. What is the meaning of this? F is a function of x and x is function of h. Chain rule. If you cancel dou x, you will get dou f by dou h. Plus again, f is a function of y and y is function of h. So you will get dou f by dou y into dou y by dou h. Similarly, f is a function of y dash and y dash is a function of h. You get dou f by dou y dash into dou y dash divided by dou h into dx. Have you understood all of you? See here f is a function of x, y, y dash and you have to take x, y, y dash as function of h. Actually you are differentiating f with respect to h directly, but chain rule means you have to use composite rule. A implies B, B implies C, then A implies C, like that. So here f is function of x, x is function of h, then how will you write f as a function of h? Dou f by dou x into dou x by dou h plus dou f by dou y into dou y by dou h plus dou f by dou y dash into dou y dash by dou h. Now here dou f by dou x, dou f by dou y, dou f by dou y dash, we cannot do anything. We shall keep these three terms as it is, but we can find the values of dou x by dou h, dou y by dou h, dou y dash by dou h. But you can see here h is independent of x and hence dou x by dou h will be 0. Why h is independent of x? Because this h we have taken for which term? Y. So you can see here we have taken y equal to y of x plus h into alpha of x. So this h is related to y, not x. So h is independent of x. So derivative of this x with respect to h will be 0. But you have to find dou y by dou h and dou y dash by dou h. How will you find out? From equation 1, our neighboring curve. Which is the neighboring curve? y equal to y of x plus h into alpha of x. Then if you differentiate y partially with respect to h, derivative of y of x is 0 because you are differentiating partially. Y of x act as constant. So derivative of y of x will be 0 plus h into alpha of x. Now you just see here h into alpha of x. You are differentiating y partially with respect to h. So alpha of x act as constant. Derivative of h with respect to h is 1. So dou y by dou h is alpha of x. Similarly, here y equal to y of x plus h into alpha of x. Therefore y dash will be y dash of x plus h into alpha dash of x. Derivative of that. Therefore, if you differentiate y dash partially with respect to h, dou y dash by dou h will be alpha dash of x. Again, you are differentiating partially. Derivative of y dash of x with respect to h will be 0 because we don't have h here. So this complete term act as constant plus h into alpha dash of x. So alpha dash of x constant, derivative of h with respect to h is 1. So dou y by dou h is alpha of x, dou y dash by dou h is alpha dash of x. So substitute these two values along with dou x by dou h equal to 0 in equation 3. Therefore, we get di by dh equal to integral from x1 to x2 dou f by dou y alpha x plus dou f by dou y dash alpha dash of x with respect to x. Or here plus symbol is there. I will write separate integration of first term plus integration of second term. Integration of dou f by dou y into alpha x from x1 to x2 as it is plus integration of dou f by dou y dash into alpha dash of x from x1 to x2. Just I have separated the term because here plus sign. So now here I will keep this first integral as it is. In second integral I will apply integration by parts. Integration by parts, you know, integration of u into v, u into integration of v minus integration of v into derivative of u. So here for this second integral I will apply integration by parts. So if you apply integration by parts, see dou f by dou y dash, u as it is, what is the integration of alpha dash of x? That is alpha x because derivative of alpha x is alpha dash. So integration of alpha dash of x is alpha x. Just understand u into v. U is nothing but dou f by dou y dash. V is nothing but alpha dash of x. U into integration of v. Dou f by dou y dash as it is. Integration of alpha dash of x is alpha of x. Integration is from x1 to x2 limit minus integration of v under integration into derivative of u. Again integration from x1 to x2, integration of v is alpha x into derivative of u is d by dx of dou f by dou y dash into dx. Okay, if you have any doubt, you just ask. Okay, in middle also you can ask in any step. So you are just applying integration by parts here. U into integration of v minus integration of v into derivative of u. Derivative of u is d by dx of dou f by dou y dash into this dx. Now this first integral as it is here dou f by dou y dash into alpha x. We shall apply the limits x1 to x2. This x1 to x2 for which variable? Only for variable x because you are going to integrate with respect to x. So dou f by dou y dash outside. In place of x, if you take upper limit, you will get alpha of x2 minus in place of x, if you take lower limit, you will get alpha of x1. So dou f by dou y dash into alpha x2 minus alpha of x1 minus second integral as it is integration of alpha of x d by dx of dou f by dou y dash into dx. Okay. Now can anyone tell me what is the value of alpha x2 minus alpha x1? Is alpha x1 and alpha x2 values are how much? See, initially we have taken at the point A alpha of x1 is 0 and at the point B alpha x2 is 0. Substitute these two values here. So in place of alpha x2 and alpha x1 both are 0. So this complete term will be 0. So remaining term is di by dx equal to integration of dou f by dou y into alpha of x from x1 to x2 minus the last integral as it is, integration from x1 to x2 alpha of x d by dx of dou f by dou y dash with respect to x. Now what I will do, see, integration limit is from x1 to x2 in both the integral. I will just combine it. First initially I have separated, now I will combine. So if you combine this integration from x1 to x2, which term is common here? See, alpha x dx is common in first integral as well as second integral. So if you take alpha of x into dx common, so inside the bracket in first integral remaining term is dou f by dou y minus in the second integral remaining term is d by dx of dou f by dou y dash whole bracket into alpha of x into dx. So left hand side is di by dh. Still we have not obtained our required result. But you can see now right hand side you have integral, definite integral, so many things, but left hand side what we have? Di by dh. So what is the value of di by dh here? Di by dh should be 0 because this is the condition for extremum. So we have already stated that di by dh must be 0 when h is 0 for I to be an extremum. So in left hand side of this above equation we shall take 0, that is di by dh equal to 0. Then if you take like that, then integration x1 to x2 dou f by dou y minus d by dx of dou f by dou y dash into alpha of x into dx with respect to x, that is equal to 0. Correct? That is equal to 0. But this definite integral cannot be 0 sometimes, but here we are getting this definite integral is equal to 0. Equal to 0 means what? Here there are two terms in the RHS. One is alpha of x, second one is dou f by dou y minus d by dx of dou f by dou y dash. Two terms are there. If this definite integral is 0 means either this first term is 0 or alpha x is 0. If alpha of x is 0, then 0 into this anything is 0. Or this dou f by dou y minus d by dx into dou f by dou y dash is 0, then 0 into alpha of x is also 0. But we have taken alpha of x is any arbitrary function. So this cannot be 0. Yes or no? Because alpha of x is with h, that distance that cannot be 0. So which function we can take as 0? Coefficient of alpha of x. So coefficient of alpha of x is dou f by dou y minus d by dx of dou f by dou y dash equal to 0. So this is nothing but our required condition. So in statement also you can see our required condition is dou f by dou y minus d by dx of dou f by dou y dash is 0. Now by using this condition di by dh in LHS, we got this dou f by dou y minus d by dx of dou f by dou y dash equal to 0. So this is the required Euler's equation being the necessary condition for the extremum of the functional I equal to integration of f of x comma y dash between x1 and x2, which means we can say that this integral I is either maximum or minimum if dou f by dou y minus d by dx of dou f by dou y dash is equal to 0. If this condition satisfy, then we can find the maximum or minimum of the definite integral I. So this is called the Euler's equation and derivation of Euler's equation, and this is the necessary condition here. So with the help of this necessary condition we can find the maximum or minimum of any type of function f, because we can see here I equal to integration of f of x y dash. So in Euler's equation also what we have, dou by dou y of f minus d by dx of dou by dou y dash of f, which means if I give one equation, find the extremum of the functional I equal to integration of x square plus 2y plus y dash. So instead of f what I have given, x square plus 2y plus y dash. So what is the condition for extremum of that particular integral? This Euler equation. So you have to substitute f here, dou f by dou y, and here d by dx of dou f by dou y dash. After finding the derivative of f with respect to y and y dash, simplify and obtain the answer. That will be the required curve in which the given integral will be extremum or maximum or minimum. In general, we say that that will be the condition for extremum of the given definite integral. So this is the proof of Euler's equation. So in brief, what we did, initially we have considered one curve y of x connecting 2 points A and B, correct, y equal to y of x. Then we have considered one more curve near to this original curve of distance h into alpha of x. The new curve is y of x plus h into alpha of x. So then instead of y of x, we have substituted y of x plus h into alpha of x in the integral I. After that, we have considered the necessary condition for maximum or minimum. So here, this two curve coincide only when h is 0. Maximum or minimum of this curve is depends on the value of h. Therefore, which condition we should have? We should have di by dh equal to 0. So this is our main condition. Then we have obtained this di by dh by applying Leibniz rule for differentiation under the integral sign. Then we get the above equation. Then apply the chain rule. In chain rule we get dou x by dou h, dou y by dou h, dou y dash by dou h. So dou x by dou h will be 0 because h is independent of x, and dou y by dou h, dou y dash by dou h can be obtained with the help of this second curve y of x plus h into alpha of x. So if you differentiate this partially with respect to h, we get dou y by dou h, and if you differentiate y dash partially with respect to h, then we get alpha dash of x. Substitute those two values in the above equation, then separate the integral, keep first integral as it is, and integrate second integral by parts, integration by parts, u into v, that is u into integration of v minus integration of v into derivative of u. Then take upper limit and lower limit in the first case. If you take upper limit and lower limit, that term will be 0 because you are getting alpha of x2 minus alpha of x1 at the point A. Alpha of x1 is 0, at the point B alpha of x2 is 0. So this complete term will be 0. Only first integral and last integral will be remaining. So we shall combine those two. If we combine, we get alpha x dx as common. So inside the bracket we get dou f by dou y minus d by dx of dou f by dou I dash. Left hand side is di by dh. But according to our assumption, di by dh should be 0 to attain I as an extremum. So therefore, if you take this term as 0, this term is 0 only when alpha x is 0 or dou f by dou y minus d by dx of dou f by dou y dash is 0. But alpha x is the distance and it is arbitrary function. It cannot be 0. So we can consider dou f by dou y minus d by dx of dou f by dou y dash as 0. And this is nothing but the necessary condition for the integral I to be extremum, which means maximum or minimum. To prove maximum or minimum, we are using this particular equation. So this is very important result. So this result is called Euler's equation to find a maximum or minimum. So this is the proof of the Euler's equation. You understood or not? If you have any doubt in any step, you just ask. Anybody? So main thing is this Leibniz rule for differentiation you should understand. When we have to use this one, see if you have integral in the right hand side and you want to differentiate that function with respect to only one variable. So left hand side you will be having only one variable, directly you can differentiate di by dh. But right hand side one thing is we have integral, second one we have x also, y of x also, y dash of x also. But our ultimate aim is to differentiate this function with respect to h. While differentiating with respect to h, we have to keep other variable as constant. In that case, we have to use partial differentiation. So the name for this type of differentiation is Leibniz rule for differentiation under the integral sign. And similarly, chain rule. After applying all this, we can obtain the required Euler's equation. So this is the proof of Euler's equation. So based on this Euler's equation, the remaining all examples, complete this half of the module. Remaining all examples are depends on this Euler's equation. To solve any type of example, we are going to use this Euler's equation. That's why this Euler's equation is very important. Okay. If you have any doubt in this concept, you can ask. Any doubt? Derivation of Euler's equation. So in exam they will ask state and prove Euler's equation. Then you have to write the statement as well as the proof. So remember, while reading this concept, you should read statement as well as the proof. Statement also you should remember. A necessary condition for the integral I to be an extremum is that dou f by dou y minus d by dx into dou f by dou y dash equal to 0. Or sometimes they will ask obtain the Euler's equation dou f by dou y minus d by dx of dou f by dou y dash equal to 0. So remaining things we shall study in our next class. Next concept is we have some other forms of Euler's equation, which means we can express the same Euler's equation in different ways. In different ways means here f is a function of x, y dash. So we can express this equation in terms of x separate, y separately and y dash separately. That is called the different forms of Euler's equation. We shall study those concepts and related problems in our next class. So if you have any doubt in today's class, you can ask. Any doubt? Anybody? So to understand this proof, as I told you, you should recall the topic what you have studied in your PUC, maximum and minimum of some function. Then relate that f of x with I. So what is the condition? Here also what should be the condition? Then you will understand clearly. Yes. Have you understood this concept? Euler's equation derivation?
Yes, sir.
Okay. So if you have any doubt, you can ask. Later also you can ask. Okay. In tomorrow's class, we shall discuss different forms of Euler's equation and related problems.